Okay, let's go ahead and get through 4.6. We're going to do right triangle trigonometry, or right triangle trigonometry. I think that's a little bit of a typo. Triangle. Sorry. Triangle trigonometry. And so here we're going to look at trigonometric ratios. Remember that inside our unit circle, we were always drawing in the triangles in order to figure out what the sides were, where this was a right triangle, this was the side x, this side gave us y, and r equaled 1. Well, we're basically going to extend this out to cases where the radius of the circle that our triangle fits in is not 1 anymore, but we're still going to have our same trigonometric relationships are going to work because they're all just proportional, and it's just a matter of making r not equal to 1 anymore. And we've done a little bit of that already. So all trigonometric functions are based off of a given angle theta. Angles are notated with capital letters. All right. So you see that here. This is that angle. This is that angle. This is that angle here. It's those angles. And then all the side lengths are labeled with lowercase letters of the opposite. Opposite angle. So you see side A is across from angle A. They're opposite from each other. Okay? And so when we get here, we have A is the length of side opposite. Basically, angle theta here, we're calling A theta. It's labeled inside of here. And the length of side B is adjacent to theta. Okay, so adjacent, right next to it, opposite, across from it. And then the length of C is the hypotenuse. It will always be across from the 90-degree angle, and it's going to be your longest side. That's always that's what that one always is. And so if we look here, we can define some of these things. Leslie, and actually I'm going to go ahead and just do this here. This is A, and this is side A. This is C, this is side C. See how they're across from each other? There you go, B, and side B, angle B. So here we go, we have sine theta. That's going to equal, we're looking here at theta, it's going to be sine, which is going to be opposite, so across from it, over hypotenuse. Hypotenuse is across from that 90-degree one. All right, so that's going to give us A over C, which is our opposite over hypotenuse. Cosine is going to be B over C, because it's going to be adjacent over the hypotenuse, which is across from the 90, so that's B over C. And tangent, if you remember, B over C, I thought that would try to get rid of these. Tangent is opposite over adjacent, so it's going to be A over B. Cosecant is the reciprocal of sine, so it's going to be C over A, right? And then secant is the reciprocal of cosine, so it's going to be C over B. And cotangent is the reciprocal of tangent, so it's going to be B over A. So I just used the 3 on the left to get the 3 on the right really quickly. Okay, and now we can move on here to the next page where we've got example 1. And so this is finding the values of the trigonometric functions. Find the exact value of the 6 trigonometric functions of the angle theta. So that's going to be sine theta, cosine theta, tangent theta, and then I'll write these 3 over here. This will be cosecant theta, secant theta, and cotangent theta. Okay, and so we need to find each of these. So sine of theta is, again, it's opposite over the hypotenuse across from the 90 degrees. So that's going to be 3 over C. But then you think, well, wait a second. We don't have C, so we need to find C first. Thankfully, this is a right triangle, and we know this value and we know this value, so we can just use Pythagorean theorem, where we know that a squared plus b squared equals c squared. And so a squared is 3 squared, b squared is, sorry about the noise, there's a moving truck driving through my neighborhood now. So 3 squared plus square root of 7 squared equals c squared, which means this is 9 plus 7 equals c squared, which is 16 equals c squared, which means that c is going to be 4. And we don't have to worry about the plus or minus here because we're not going to have a negative length of a hypotenuse here. So this becomes 3 over 4. And then cosine of theta is going to be the adjacent side right next to it, over the hypotenuse, which is across from the 90. So that's going to be square root of 7 over 4, because we now know that this is 4. And then tangent is going to be opposite over adjacent, which is going to be 3 over square root of 7. And then for the last three, I just have to do reciprocals. So this is 1 over sine of theta, which is 4/3. This is 1 over cosine of theta, which is 4 over the square root of 7, which would be 4 root 7 over 7. We multiply the top and bottom by square root of 7. I didn't write that very well. 4 root 7 over 7. Multiply top and bottom by the square root of 7 to get that. And then cotangent is the reciprocal of tangent, which I probably should have written as 3 root 7 over 7. Multiply by root 7 over 7 again. But it's going to essentially be square root of 7 over 3. And I took that from this first version, so I wouldn't have to worry about the radical in the denominator. Okay, so that takes care of that example. Let's try another one here. Finding the remaining trigonometric function values here. Find the other 5 trigonometric functions of value theta, given that theta is an acute angle of a right triangle with sine theta equals 2/5. So what we're going to do is draw ourselves a nice right triangle, best I can. And so let's say there we go. There's our right triangle, and we're going to get something like this. We'll call this theta. That'll be our right angle. We know that the sine is 2/5, so that means the side opposite we're going to count as 2, because it's 2/5. Remember, this is opposite over hypotenuse, and then we're going to count the hypotenuse as a 5, right? Oops, not from there. The hypotenuse across from the 90. So we're going to do that to figure out that that's 2 and 5, and then after that, we have this side here. This is A, this is angle C, this is angle B, just as before. We need this over here, this side here. And so we can do the Pythagorean theorem again. B squared plus 2 squared equals 5 squared, right? This is B squared plus A squared equals C squared. And then what we can do is solve that for B. You'll have 25 from the 5 squared minus 4 from the 2 squared, and then we have to square root it. So this is going to be the square root of 21, which means I can bring that over here and we can say that B equals the square root of 21. And now it's just a matter of writing these. We already know that the sine of theta is 2/5. We have our triangle figured out, so we can do cosine of theta. That's going to be adjacent over hypotenuse, so square root of 21 over 5. Cosine, let's do tangent of theta. That's going to be the opposite over the adjacent, so that's 2 over root 21, which is 2 root 21 over 21. And then we have to do the other three, cosecant of theta, secant of theta, and cotangent of theta. So let's do each of those. Cosecant, just reciprocal of sine, 5 over 2. Secant, reciprocal of cosine, 5 over root 21, which is 5 root 21 over 21. And then cotangent is just going to be, I'm going to use that one just to do the reciprocal. It's going to be root 21 over 2. And there you go. There are all of those. All right, next we want to look at complementary relationships. Basically, the value of any trigonometric function of an acute angle theta is equal to the cofunction value of the complement. Essentially, that's just the complement of theta.